All right, guys, so let's begin with the Lewis structure for carbon dioxide. Okay, so guys, tell me, where do we begin for drawing a Lewis structure?
Find the center.
Not finding
the electrons.
the valence electrons. So carbon is how many valence electrons?
4.
4,
Oxygen is
6
6 times
times
2 giving you 12, right? Okay, what is the total
16.
electrons? Now you pick the central atom. Who's going to go in the center, carbon or oxygen?
Carbon.
In the center, then you have oxygens on two sides. What do you do next?
Make the bond.
Make the bond. That's the first thing you do. So you make a bond between them. When you make the bond, how many electrons have we used here?
4.
We've used 4 electrons. So out of 16, we already used 4. So how many left?
12.
12. With 12, how do I split these 12 electrons?
6 each.
6 times
The outer ones first, right? So you try to split them evenly with the outer ones. So you can do max 6. So once you do 6 and 6, 12, that took care of these 12 electrons. Okay. Now, are we done, guys, after we place all the electrons?
No.
No, you gotta check. Okay.
We got to check the octet, right? Now, is this oxygen happy with the octet?
Yeah.
Yes. So you see 1, 2, 3, 4, 5, 6, 7, and 8. So this has 8 electrons. This oxygen has 8 electrons total shared. What about this carbon? Is this happy with the octet?
No.
No. This carbon has 1, 2, 3, and 4 electrons, right? So this carbon is not happy. So how do you help this carbon? You make a double bond. So you ask this oxygen. So once you do this, you got this oxygen right here with a double bond and this oxygen as it is. Now, is the carbon now happy? Is it done?
No.
No. You have to do the same thing again. Again, we did this in this last lecture, so I'm gonna go over this real quick. So you see that we get this structure, right? Now is carbon happy with 2 double bonds?
Yes.
Yes. So this is your final structure, right? Final Lewis structure, where everyone is happy with the octet, and that's where you stop. Right, guys?
I have a question. Why did we subtract 4 and it become 12 from 16?
So you see we have total 4 electrons from carbon and 12 from oxygen. So first of all, we total that to get a 16.
Right.
Now, when I place the central atom carbon, when I did this, carbon and oxygen, you see first you need to spend the electrons to make the bond. So there, when you made that bond, this bond means 2 electrons. This bond also means
that 4. Okay.
4.
Got it.
That's what that -4 is.
But it's 16 total, but we just subtracted the 4 because we made the bond. And
Yes,
then-
16 is a total, yes.
Okay.
Then, so we're keeping track of how many electrons we've already put into the Lewis structure. That's what we're doing here in this part.
Okay. Okay. Got it. Thank you.
Okay. Now, guys, are we good with the Lewis structure for CO2?
Yes.
Okay, now, guys, now get to the point, pay attention here. So, again, guys, you'll have to very carefully listen to me today to understand, not that other lectures you should not, but for this part, you have to pick, what you have to do is you have to look at this chart. So first of all, we need to look at this. So this table, again, you guys have this already with you. Again, if you lost the copy that I gave you, you just go to Canvas and look for the electronegativity and molecular geometry chart. It will say shapes and electronegativity. So find that document, you'll find it under handouts on Canvas. Now, getting to this chart that we have. You see this chart has some details. It's the first column that you see, it's talking about how many electron groups do we have. Electron groups basically mean, guys, that your central atom has how many neighbors next to it, okay? So let me give you guys an example here. So guys, imagine that you have, in the center, you got an atom called A.
I could get you.
Yes, you get a, all right. So guys, you got a central atom A, and imagine it's bonded.
Sorry.
That's okay. Imagine it's bonded to. Let me do that here. Yes, let me go back to the OneNote. All right, let's do that here. So guys, let me ask you, if I put a central atom A here, and then it has these outer atoms, can you tell me this central atom A has how many neighbors?
4 neighbors.
4.
It's 4 neighbors, right? So when I say it has 4 neighbors, that means it has 4 electron groups. You see the electron groups? So then I'll go to this table and then I'll look at these four. You see, I mean, this four, this four, and this four. So it could be one of these three. We'll talk more which one to pick, but for right now, this is the number that we're talking about. The total number of groups, total number of neighbors. Okay.
Are you counting the bonds?
Yes, we're counting. We're not counting the bonds. We'll get to that. I'll give you some more examples. Okay. Let's do that first. So this, guys, you understand it's four neighbors. Now I'm going to give you another example. Now with this case, tell me how many neighbors does this A have?
Four.
Does
Four.
it have, or does it have three neighbors? What are you going to say? Four neighbors?
Four, because it has the double bonding, right?
The double bond, do you think having a double bond gives it a extra neighbor?
Uh-huh.
No.
No, the double bond doesn't
So
matter
only-
as long as.
Yes, double bond still means you're shaking one hand with your neighbor or two hands with your neighbor. Does that increase the number of neighbors you got?
No.
Right? So this central atom has three neighbors, this X, and this X.
Yeah.
So you don't count the bonds literally. You're just looking around and seeing how many neighbors it got. It's a single bond, double bond, triple bond, doesn't matter. Okay? I'm going to give you one more example, guys. Now look carefully at this one. I have this example where I have central atom A. There's X, there's X. Now there's X here as well. But then I have a lone pair on A. Now, remember guys, the lone pair itself counts as a neighbor. So now answer, A has how many neighbors?
Four.
A has four neighbors. So if it's a atom bonded, the outer atom, or if it's a lone pair, both are going to count as a neighbor. Okay.
Okay.
So for right now, understand that it's a neighbor. Yes, there are different kind of neighbor. This is a lone pair neighbor, and this is a bonded neighbor. Yes, we are going to make that. We are going to distinguish that. But just to see how many total we got four total. Does that make sense?
Does that change the like the section that we check for the electron groups
Exactly.
instead of
exactly.
3 to 4?
Exactly. That is what is actually going to make a difference between this 440, 431, and 422. Okay, so let's talk about that right now.
Yeah.
So again, answer guys, this first one, the one that we did first, A with 4X. How many total neighbors do we have? What should I say? We have total 4 neighbors.
Four.
Out of these 4 neighbors, are all of them bonded neighbors?
Yes.
Yes.
So I'm going to say it's 4 bonded neighbors. Okay, so the first is the total. Then the second is the bonded. And now tell me how many lone pairs does A have?
0.
0. 440. So the last one is for the lone pair. Okay. Does that make sense, guys?
Yeah.
So now, do you guys see that these two numbers, this 4, so you guys look here on the screen, this 4 and this 0, this should total to this first number. Does that make sense? So these two numbers must add up to this first number because the first number is total. And then you have bonded in the lone pair. Okay? Now let's do the next one, guys. For the next one, tell me how should I fill this out? How many neighbors total?
3.
3 neighbors.
3 neighbors, out of which how many are bonded?
3.
3 are bonded. How many lone pairs?
0.
0.
Okay. Now let's do the last one. How many neighbors total?
4.
4 neighbors. How many are bonded?
3.
3.
And how many lone pairs?
1.
1.
Do we get this, guys?
Yep.
Okay. So now one more thing. Let me give you one more example. So let me see, I have A in the center, and then I have X, and then I have X, and then I have X. And then imagine this is like one of those examples that we did earlier where the outer atoms had the lone pair. Now, what you need to remember, guys, is that table that we were seeing earlier, or these numbers that we were just giving, these formulas that we were making, 440, 330, 431.
Uh-huh.
It only cares about the central atom. So never confuse yourself by these outer atoms for their lone pairs. So what I'm trying to say is, tell me guys, for this, whenever you're going to answer this question, like how many neighbors and all of that, your focus should be on the central atom. So tell me, for this case, what will you say? Total, how many neighbors does A have?
3.
3.
Out of which, how many are bonded?
3.
3.
And then how many lone pairs?
0.
So this is what you need to realize, that this lone pair or the bonded ones is only for the central atom. We're counting for our focus is on the central atom and nowhere else. So when you're counting lone pairs, never count the lone pairs from the outer atoms. We don't care about the outer atoms. All of this info, all these numbers belong to the central atom. Okay?
Yeah.
Now, why are we doing all this, guys? Is so that we can read this table correctly, and then we can tell what is the shape of our molecule. So you guys look here on the screen. You see in this table, we have this thing called molecular geometry. This is our focus. Okay, you don't have to worry about the electron geometry, so don't worry about that. You need to answer this molecular geometry part. Okay, now you're going to answer this for CO2. Okay, now what did CO2 look like? I'm just going to draw that real quick here. So CO2, you guys see this is what CO2 looked like? Right? We did the Lewis structure already for CO2. Now, try to answer that same question. So tell me how many total groups. So guys, you see here, electron groups is our total neighbors. Then we have the bonded neighbors, and then we have the lone pair. So you guys might see these words group and group. Don't worry about that. Electron groups mean total neighbors. Then you have bonded neighbors, and then you have lone pairs. Okay, now guys, answer this question. Our central atom carbon has total how many neighbors?
2.
2 neighbors. How many are bonded of those 2? 2. And how many lone pairs do we have?
0.
0. Is everyone able to understand that?
Yeah.
Why it's 220? Okay, so if you understand it's 220 for CO2, tell me what is the molecular geometry for CO2 going to be?
Linear.
Yeah, linear. So this is what you're reading, okay? You're reading this way. 220 is linear. So you can tell me that it's linear. With that, can you tell me what is the angle going to be? Like this, you see the CO2 is what it looks like. I'm not worried about the lone pair or the double bonds. I'm just asking you, if you have this main structure of CO, what is this angle going to be between the central atom and the outer atom? What do you guess this angle is?
180.
180.
180 degrees. And that's given right here, 180 degrees.
Okay.
Okay. So this is how you're going to read the table. So it's not, if you get the Lewis structure, there's nothing difficult in this. You have to just find the number of neighbors and just match it with this table. Then you have the table on the exam. Okay. So you're going to make sure that when you're taking the exam, you have this table handy.
Okay. Yeah, so for the lone pair, that only goes for the center atom, correct? So like for carbon or whatever's in the middle, that's where the lone pairs are always going to fall under.
Yes. All this counting that you're doing, that's this 220 thing that you're counting, that's focused on the central atom only. We don't care about the outer atoms.
Okay.
Because it's the central atom who is going to decide the shape of the molecule.
When we're talking about bonding, we're just talking about like the oxygens being bonded to carbon. We're not talking about the actual like double or triple bond.
Yeah, that we don't care about. Yeah, we just care about total how many neighbors. Out of those neighbors, how many neighbors are bonded. Yeah. Not that it has a double bond or triple bond or single bond. That we don't care.
Okay, thank you.
Okay.